kinematic equations. So first, to start with the simplest, this is velocity final. So velocity final equals velocity initial plus acceleration times time. You may also see velocity initial denoted as v naught. So when you're using this equation, or maybe any of these equations in general, it's important to think of acceleration as force over mass, because that could come in handy if you have to solve for the forces acting on an object. So in this equation specifically, it's assuming that there is a constant acceleration Some basic problems of this would just be like a car accelerating on a highway. Just an object with a constant acceleration is what kind of problems you'll see with this. And this will show you that there's like a linear, it's linear between the, it acts linearly when there's constant acceleration. There's not any like exponential changes or anything. So right here we have displacement. So delta x, you could just think of as displacement, just changing the x direction in this case. It could also be changing the y direction. It just depends on the circumstances in the problem. So this is delta x equals velocity initial times time plus 1/2 acceleration times time squared. This equation could be used like if an object is dropped from a tree, like if an apple falls from a tree, you could use this to solve for the displacement if you're given all the variables, of course. That's really just how these physics problems are. It's a lot of just plug and chug and understanding the equations and when to apply them and just seeing what variables you have and what you need to solve for. Okay, now we have these other two. This one specifically you would use when you don't have like a time variable. You see in these two other equations you have time. If you're not given time, you could use this to help you solve for velocity final, and then which you could plug that into those other equations to solve for time. And then this other equation that solves for the displacement, this one assumes a constant acceleration as well as, so these two, this equation and this equation up here, both, here, let me erase this. So these two equations both assume constant acceleration for them to be able to work. But this is just another way to solve for displacement if you're given velocity initial and velocity final. This would just be like the distance covered by an aircraft during a landing. So it's like it gives you the velocity initial. You just plug and chug, basically all there is to it.